Greetings folks, welcome. In this video we're going to have some fun in Excel. We're going to do some basic regression analysis. And as always, there are some caveats we need to cover when working in Excel. The first one is that different versions of Excel look different. I'm using Excel on a Mac, and if you have Excel on a PC, things might look a little bit different. This is actually good practice because you never want to get too attached to any particular version of any computer software because things are always changing. And second, there are different ways of doing things in Excel. And even beyond Excel, there are lots of other econometric software packages that people could use for regression analysis. But I think the way I'm going to lead you is a pretty good approach for beginners. Again, a more advanced user might take a slightly different approach than what I'm going to use. So when we jump into Excel, we're going to estimate a regression model that looks at the effect of education on income. So income is the dependent variable, and education is an explanatory variable. So if you just think about this regression model, it's an idea of how I sort of think the world works. In other words, I think that education has an impact on income. And then the second line you see here is the actual regression model that we calibrate with data from our sample. And that's income equals B naught hat plus B1 hat times education. And when we estimate that B1 hat, that's referred to as the estimated coefficient. And it's an estimated coefficient corresponding to the education variable. In other words, it tells us what happens to income as you increase education by 1 unit, or in this case, 1 year. And sort of a nice feature of doing regression analysis in Excel or any statistical software is you actually get all the information that you need to do a formal hypothesis test. So in the example we go through, I'm going to test a claim that I think education has an impact on income. And again, that's a claim for an entire population. So it's a claim about the beta 1 parameter. So I set up the claim as my alternative hypothesis, which is H subscript A, beta 1 is not equal to 0. Again, I think education has an impact. I'm testing that against a null hypothesis where education doesn't have an impact on income. And if that were the case, it would be H subscript 0 or H subscript naught is beta 1 is equal to 0. The second step of the hypothesis test is setting the significance level, and I'm setting it at alpha equals 0.05. That means there's a 5% chance I'm going to make a type 1 error of rejecting the null hypothesis in favor of my claim. So the third step in doing a hypothesis test is calculating the test statistic. So the formula for calculating the test statistic is B1 hat. Again, that's the estimated coefficient corresponding to education from my research. And I subtract from that the value from the null hypothesis, which is beta 1 naught, which of course in our hypothesis, that's equal to 0. And you divide that by the standard error of the sampling distribution for B1 hat. So you'll see in a second, when we jump into Excel, that we can use computer software to come up with our estimated coefficients, which we refer to as the B hats. And computer software, or in this case Excel, will also give us the standard error. So again, we'll have all the information that we need to conduct our hypothesis test. So here's sort of a quick overview of what we're going to do in Excel. When we jump into Excel, the first thing we'll do is look for the data menu. And then under the data menu, we'll find the data analysis tool. And this might be something that you need to load into Excel. You may or may not have that preloaded in your version of Excel. And then under the data analysis tool, we'll look for a regression. And then when we do the regression in Excel, we have to do what's called inputting the Y range. And this is the dependent variable, which in our case is income. And then we need to input the X range, which is the explanatory variable. And in this case, we're only using one explanatory variable, which is education. So all right, I think that's all we need to get started in Excel. I'll see you there in a second. All right, folks, welcome to my Excel spreadsheet here. Let's make it a little bit bigger so we can see what's going on here. You see we have 3 columns of information. Column A is just an ID number, an identification for each of the observations. Column B is years of education, so you see like 13 years, 20 years, 11 years, 2018, etc. And then column C is total personal income. Because again, we're going to do a regression analysis that looks at the effects of years of education on somebody's income, and it's measured as just total personal income over the course of a year. So now let's jump into the regression tool. So we'll start by clicking on the data menu, and then we click on data analysis, which is a tool. Again, this is something you have to load into Excel. So not every version of Excel is going to have this preloaded, but it's pretty easy just to load this tool into Excel. And then when you click on data analysis, you get all the specific tools, and regression happened to be selected because this is something I use on a pretty regular basis, and we will click OK. So now we have this box that opened, and as promised, there's an area where you input the Y range and you input the X range. Of course, Y is the dependent variable and X is the explanatory variable. So in Y, we'll put total personal income, and in the X range, we'll put years of education in a second. And I am going to click labels because it just helps us later on, once we've done the regression analysis, to kind of keep track of things. You'll see what this means in a moment. So now let's input the Y range. And so I'm going to start by clicking on the cell C1, and I'm just going to drag all the way down to capture the dependent variable, again, which is total personal income. It's going to take a second to grab all this. Won't be too long, though. I can feel the anticipation building as we're setting up our regression analysis. All right, we're almost there. We're at a couple thousand observations. And there we go. All right, so we have entered our dependent variable, or the Y range. Now I'm going to click on this, the X range. So let's grab the education variable. And since I'm at the bottom of the spreadsheet, I'm just going to start from here and work my way up. Or if I wanted to, I could go up to the top and pull it down. Or if I was really adventurous, I could just type in the values. But I will show you what happens when you sort of enter it by hand here. Again, we're looking at all these people and how much education they have. Oops, keep going. Every once in a while, my cursor goes over to the A column, so I just have to make sure when I'm done that I don't accidentally have the A column as well. All right, so it looks fine here. So now if you look it over, your Y range is C1 to C3104, and your X range, which is the explanatory variable, is B1 to B3104. And I've clicked labels, and we'll see what that means in a moment. And my output takes us into a new worksheet. So when I press OK, it'll run the regression or do the regression analysis, and the results will open up in a new worksheet. All right, let's count it down here. 3, 2, wait, are you ready before I go? 3, 2, there we go. Okay. And it's doing a regression analysis, and sure enough, it popped up into a new window. And I'm going to enlarge things here. So this gives you a lot of information, and it gives you an R squared. It gives you an adjusted R squared. It tells you the number of observations. There were 3,103 observations in the data set. What we're most interested in are the regression results. So here we have an intercept and a years of education. You might remember that when I set up the regression, I clicked the word labels, and because of that, it has years of education here in this column. If I had not clicked label, it would just show up like generically. It would say like variable 1, something like that. So again, that's why you click on labels, so it reminds you of the variable that you have as your explanatory variable. So just to give you an idea, well, let's make this a little bit bigger here. So coefficient, this is what we call the B1 hat. This is the estimated coefficient that corresponds with years of education. This is the standard error. This is a t-statistic, testing the hypothesis that years of education has an effect on total personal income. So you might remember that is the B1 hat minus the value from the null hypothesis, which is 0, divided by the standard error. So it's really just this estimated coefficient divided by the standard error. If you don't believe me, we can say equals what's in B18 divided by what's in C18, and you get that same value for the t-statistic. And then it gives you a p-value, and this is actually scientific notation. This p-value is practically 0. It's 8.4979 e to the minus 69. So it's 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So there's very, very, very low support for the null hypothesis that education has no effect. So in other words, we can reject the null in favor of our claim that education does have an effect. In fact, as you increase years of education by 1 year, it increases your total personal income by about $8,900. And I'm going to actually round it down here. So you see it right here. An additional year of education has an effect of $8,922. So again, just to sort of summarize, these are the results from our regression analysis. You've got the R squared, you've got the adjusted R squared, you have the number of observations in your regression analysis, you have your estimated coefficients. This intercept is the B0 hat, the coefficient that corresponds with years of education is B1 hat. You've got your standard error, your t-statistic, your p-value, and then you've got some other information in here as well. So I think that's it. So now you know how to run a simple 2-variable regression model in Excel.